Okay, guys, so here is, I want to finish that one problem that I had changed in the packet from the previous year, which is why the notes didn't match up. So pretty similar question. Most of the stuff is going to be exactly the same. Okay, the only difference is with this one. So the first two examples, you were given a graph defined as an integral and you had to conclude that it was a derivative graph. This one, you're straight up given it's a derivative graph, okay? And then the first set of questions ask you about f, right? So again, if I have a derivative and I'm being asked about the original, I know I have to integrate, and I know to integrate a graph, I have to do area. The thing is, you're like, well, where do I integrate from if they didn't give me an integral? Well, it still goes back to the same rule we've been using for integration. You integrate from what you have to what you want. So because I do have this initial condition right here, that means -2, which is right here, is the line that I'm going to be doing all my integration from. And I'm going to add 3 to all those areas. So the first thing here, so if I want to find f of 0, I have to integrate from -2 to 0 and then add 3 back to that. So this is going to be 3 plus whatever area goes from here to here. So that combined area is 3 because it's above the x-axis and I'm going to the right of my integration line. So that y value would be 6, okay? F of 2 means integrate from here all the way to here. It's all above the x-axis, so it's going to be the 3 plus this total area, which is 3 plus pi. So giving me a 6 plus pi y value, okay? F of 4 is to go all the way up to here, so this is going to be 3 plus 2 pi. So that's going to be 6 plus 2 pi. And then finally, f of 6. So I have this 3, I have this 2 pi, minus that 2 is going to be 1. These 2's are going to cancel each other out. I'm going to end up with 3 plus 1 plus 2 pi for a total y value of 4 plus 2 pi. Okay, so the difference between this is you have to figure out what number you're supposed to be integrating from, and it'll always be whatever your initial x condition is. So f of -1 is still going to the right, so this is going to be 3 plus 2, which is 5. This we know is just integrate, you get 0 plus the initial condition is just the 3. F of -3, so now I'm going backwards. However, do you see, again, going backwards from -2 to 3, that combined area cancels each other out. This is just going to be 3 plus an area of 0, so it's also going to be 3. And then finally, f of -4 is going to be 3 plus, okay, so the area here, so this cancels out. Now again, I am integrating backwards, so this below actually is going to count as a positive one now to give me a y value of 4, okay? Now, for the derivative part, remember the derivative is just the y value. So this initial condition doesn't matter. It doesn't matter what number I'm integrating from because again, I just want the derivative. So these answers will be the same as what was in the packet. So again, f of 4 is the y value at 4, which is 0. Okay, f prime of 2 is the y value here, which is 2. F of 6 is -2. I'm sorry, f prime of 6, and f prime of -3 is the y value at -3, which is also -2. Again, the double prime, if you have a derivative, double prime is slope. So I need the slope at 2, which that slope is just 0. I need the slope at -1.5, which is right here, which is also just 0. And the slope at 5, 1, 2, 3, 4, 5, puts me right on this line. So this line, if you just count boxes, goes down 2 over 1, has a slope of -1, okay? Now the follow-up questions, again, doesn't matter what number you're integrating from, I'm just working off this derivative graph. So remember, REL-MINs happen anytime the graph crosses the x-axis, but it has to cross from negative to positive. Right? So that's right here. Right here would be my min at -2.5. Again, justify is because f prime of x changes from negative to positive. Okay, that should always be our justification for a REL-MIN. Decreasing is like any derivative. It's where the derivative is negative on a derivative graph. That means below the x-axis, right? So that is from here. This is from -4 up to -2.5. And then the other spot it happens is 5 to 6. Okay, don't worry about the hard brackets, soft brackets, the AP, it doesn't matter. And this is because f prime of x is negative. Okay, point of inflection is where the second derivative changes sign. On a deriv graph, the second derivative is slope. So I have to see where the slope changes from positive to negative or negative to positive. So the first place that happens is right here at -3, right? It also happens, again, do we see it doesn't happen here because here the slope is changing from positive to 0. That's not a change in sign. So neither here. So the next spot it happens is right here at 0. And then the next spot it happens is up here at 2. Okay, and that's all because f double prime of x changes sign. You could also say the slope of f prime of x changes sign because they mean the same thing. Okay, concave up always means where the second derivative is positive. So again, second derivative means slope. So I need sloping up. So the first place we slope up is right here, which is from -3 to -2. Then we slope up again from 0 to 2. And it looks like that's the only other time we slope up. Yep, we're done. And this again is because the second derivative is positive. Okay, maximum value, it said maximum value of f, okay? So that's the original function. So remember with a maximum, right? Okay, things that should go on. So my x, my candidates, we say, right? So the candidates here are the endpoints, which are -4 and 6. Sorry, -4 and +6 are my endpoints. Now, up in these parts, we already found the y values to go along with it. Now remember, since we're trying to maximize f, we need the y values of f, which we found up here. So -4, we found the y value to be 4. And at +6, that was in D, we found it to be 4 plus 2 pi. So already this one is winning. But remember, the other candidates is when whatever you're trying to maximize, so whatever this says in my table, it's wherever its derivative equals 0. Okay, so now again, we don't have an equation to solve, but we just need to know where the derivative graph equals 0. So the derivative graph equals 0 at 3 places, here, here, and here, right? So I have -1.5. Okay, I have 0, and I have 1, 2, 3, 4. Okay, now -1.5 I don't have to worry about because it's a relative min. So a relative min can't be the maximum value of the graph. So I can just ignore it, or if we did, we could have, I don't know if we found the y value before, we could just put it in. At 0, we know the y value is 6, but technically if you weren't sure whether you had to find that or not, that's not a max or a min, so it really can't be the relative max or the relative min. That's fine though, but we could just throw it in there. And at 4, up here, we already found the y value of, did we ever find the y value at 4? Right here is 6 plus 2 pi. Okay, so if we look, the maximum value of f is right here, right? Technically, they want the value, so the answer is 6 plus 2 pi, but if you want to add in and at x equals 4, that is fine. Okay? So that's that one. So again, not much will change on this one when we have the change in how we worded the question, except for anything that involves finding the y values of f. Okay, so it really just be this part of the table, and A through H is the only thing that would change. Okay, so while I'm here, I want to do one more rate problem. Okay, so the rate problem I want to do is this bananas problem. So the bananas problem was in the notes packet. It was actually, I think it's the last question in the packet, number 8. Okay, so in this one, you are given the you're given 2 equations, and they are both rate equations. We have a rate of bananas removing, so this is removed, okay? And you have a rate of bananas added, okay? Now, one thing to note is they have different intervals. we're removing bananas from the time the store opens, but we don't start adding bananas until 3 hours in. So that slightly tweaks it. That's why I want to do this one. This is a slight change in an in and out problem. So I still have an equation. Now again, notice too, I hate the way they gave it to this one. They gave you the removing first and the adding second. So the rate of on the table, right? So again, always 3 rates. The rate of on the table is really G of T minus F of T. So it's backwards. It's the adding minus the removing, right? So that would be the on the table rate, okay? So remember, there's 3 equations going on. So the first thing I'm going to do is pop those equations into my calculator, right? So I have my removing, my adding, and then this one, instead of y1 minus y2, I just had to reverse it. It's y2 minus y1, okay? So again, I can do a number of things with each of these equations. I have to just read and see, okay, what are they asking me to do? What do they really want in this problem? So in part A starts off with a how many pounds of bananas. So that's a amount they're asking for, which means I'm gonna have to integrate something. It says how many bananas are removed in the first 2 hours. So removed is only this equation number 1. And by the way, there is an initial condition in this problem. At opening, there are 50 bananas on the table already. Now, that affects only 50 on display. So that initial 50 is not going to factor into this integration equation because they just asked me how many are removed. It doesn't matter how many are there to begin with. We only want how many are removed. So all I have to do is integrate the f of t equation from its starting point, which is 0, to what I want, which is 2 hours. Okay, so we just plug that into the calculator. We round it to 3 decimal places. They didn't tell us to round anywhere else. So here we get 20.051 bananas. Okay, now in part B, they ask us to find f prime of 7, right? So sometimes they ask it a little different. Sometimes they'll tell you what to do, but then they'll ask you to interpret it. So f prime of 7, that's fine, right? So I could just use my calculator, do the derivative of what I have in y1, and I get negative 0.8112, right? So the question is, using the units, explain what this means. So again, you have to remember that f is the rate of removing, and I just took a derivative. So what ends up being in this problem is the rate of the rate. Okay, now since it's rate of the rate, this equation is already measured in pounds per hour. So this unit is now going to be pounds per hour squared. Okay, and again, and if you're explaining it, just explain, make sure you, again, it is the rate of the rate is a nice way to do it. You could also say the rate of bananas removed is decreasing. That's another way to say it, or you could just say rate of the rate of bananas removed. And again, don't forget to mention the time, right? You always want to bring in the time. This is only at t equals 7, okay? Now, part C asks us, is the number of pounds of bananas increasing or decreasing at t equals 5? So remember, anytime they're asking you about increasing or decreasing, that's another way of asking you for the derivative. Now again, they want the rate. Well, those are the equations I have. So this is one where we'd just be plugging into one of our equations. Now again, we have to figure out which equation are we plugging into. Since it asks for pounds on, it asks us to describe the pounds on the display table. That is this third equation. So I have to substitute 5 into y3, what I have in y3, okay? So that is because they're asking me to describe the amount on the table, I have to plug into the derivative of on the table. So that's what this is, the rate. Again, I don't care what the number is. I really just care whether it's positive or negative, but I can show my work with the number. And now I know that they are decreasing because G of 5 minus F of 5 is negative, okay? Okay, finally, part D. So part D gets a little tricky here, okay? So part D says how many pounds are on display. So again, this is a how many pounds, which means I'm integrating one of my equations. okay? And in this case, I want on the display table at t = 8. So there's a couple ways to do it. So in the notes, I did it one way. That's fine, okay? We could do it a different way. We could also think about it as this way. So what I can't do, the problem is I know I need it at time t = 8, but the problem is I can't just integrate this equation from 0 to 8 because they have two different start times. So what I can do is I can start with my initial condition of 50. Okay, and then I could add in all the bananas I'm adding. Now the bananas I'm adding, I only start adding bananas from 3 to 8. Okay, so I'm going to integrate the G equation and I'm going to add that amount to my original 50 on display, but that's only from 3 to 8. But then I have to minus the removing, but the removing, do you see, has a different starting point from 0 to 8? And I could also do it like this. Okay, so again, I gotta throw in my DTs here. Okay, this is again just a matter of typing it into the calculator. So I start with my 50, I add bananas from time = 3 to time = 8. So I'm only integrating the adding equation, and then I minus the bananas from 0 to 8. So I have to do it a little bit differently only because they both have two different starting times of where the integration begins. Again, I just plug it into my calculator. I get 23.347, okay? So this one didn't ask anything about maximums or minimums, but remember, if they want the maximum amount removed, so again, that would mean I would just be finding the amount removed at 0, the amount removed at 12, and set the derivative of removed, which is this equation, equal to 0. So it just depends on which one. If they want the maximum added, I would find the amount of bananas at 3 by integrating, the amount of bananas at 12 by integrating this equation, but then I would set this exact equation equal to 0, okay? If I wanted to find the other candidates, okay? But otherwise, so this one was pretty straightforward except for that one little tweak on the starting times. Okay, guys? Hope that helps.